And we are here we have everyone. We have the live stream who is started and we are now recording. So let's welcome our first talk from Carolina, who will talk about how we task satellites to take picture at Planet Lab. So Carolina, this is your turn.
Thanks a lot. Thank you very much for the welcome. And so I will start and share my screen and start with the presentation. Yeah. So thank you very much. I am really happy to be here. I joined Planet last year, almost a year ago. And of course, because of the pandemic, I have not been able to meet my colleagues in person, but I was able to work with a great company and with a really great team. So yeah, here is my email address in case you have some questions or something you would like to ask further. I'll be happy to answer them. Okay, so let's start. As you might probably heard from our CEO, Will Marshall's Planet mission is to image the whole world every day, making change visible, accessible, and actionable. Our mission has remained the same since 2010, when Planet was founded, and we are working every day focused on our mission. So now I'll let you know which satellites we actually use to make our mission achievable. We currently have two constellations of satellites, the PlanetScope satellites and the SkySat satellites. For the PlanetScope, we have more than 180 satellites in orbit, and they are taking the images that we consider medium resolution, while the SkySat constellation is integrated by 21 satellites, and they provide the high resolution images. But to have a better understanding of the differences, I'll show you a video. So yeah, we see the Earth, the rotation, but we can also see in this video our PlanetScope satellites flying around the Earth at 98 sun-synchronous orbit, and they are taking a 3-meter resolution. The SkySat constellation, they are capturing images that can reach 50 centimeter resolution because they fly at lower orbit. But similar to the PlanetScope satellites, they also fly in a 98 sun-synchronous orbit. Almost all of them. I have to emphasize that we launched a group of satellites for the SkySat last year, and they are flying at an inclined orbit, as you can see in the video, that has 53 degrees. And something you might not be able to realize from this video is the size. So the PlanetScope satellites are similar to a shoebox, and the SkySats have a size similar to a washing machine. So it's still very, very small. And in this part, you can see also the PlanetScope images. We take images of broader areas, while with the SkySats, we focus on smaller areas, and of course, we have a higher resolution. Okay, so before we reach to the point of having such imaging capacity, we've learned from experience that the traditional approach on getting images, it has its challenge. So one challenge can be the limited coverage of the Earth or the low revisit that we can have over a specific place. We also have faced some challenges of inefficient access of the products, and maybe having also products that are not useful or satisfying. So now our current approach is to image the entire world, as I mentioned already, using our PlanetScope constellation, constellation. With daily imagery, chances to detect anomalies, take action, and capitalize on change are highly possible. So now with the global coverage and the frequent revisit, we also work on easy and efficient access of the products. And one of the tools that allows us to access our products is the tasking dashboard, which is the tool that I'll be explaining later on. But what makes the Planet stand out, or what drives value for our users? We believe that is the combination of the high cadence that we work based on the user requirements, the global coverage that we can reach due to our constellation, the efficient delivery that we have for our products, and the open and accessible and open platform that we have developed for our customers. And after having saying all of this, what we do is work on providing solutions to the needs that are now coming more often. So the solutions that we offer are categorized in 4 groups: planet monitoring, planet base maps, planet tasking, and planet analytic feeds. In this presentation, I will focus my talk in planet tasking, but if you want to have more details about the other solutions, we have detailed information in our website, so feel free to check it. And from this point on, I will also focus on the tasking for the SkySats only. So I talk about the company and the satellites, but not about my job. So what is my role? As a satellite tasking engineer, I focus, or I mainly work with other planning and monitoring. So what does it mean? And another is a request of having captures over a specific area of interest. So my team focuses on arranging and managing the image acquisition of the areas of interest. One example can be this area where we aim to get some features, for example, land or water, but we can also get requests of having images over specific spots. Once we ingest the order, is how we called, we also have to track and monitor the order so that we make sure that everything is correct, or if not, we are able to take action and do the arrange that might be needed. After we get the images, of course, they need to have a quality control process before it's delivered to its end user. And the story that comes after the image is delivered is so broad, as we can now see much more features that we were able to see before. And I'll show you specific examples of very nice images. So in general, what we offer with the SkySats is image at 50 centimeter resolution. We also offer monthly, weekly, daily, or sub-daily collections, also transparent and automated access to the imagery acquisition, and we also have archive data. What are the main products that we offer? We have point collects and strip collects. As you can see on the slide, the point collects have a dimension of 5 by 5 kilometer, while the strip collects can have also 5 kilometer width, but can reach up to 100 kilometer length. But each collect is composed of individual scenes. So we have 3 cameras on board each satellite, and this is the reason why you see these 3 strips. And we are capturing overlapping scenes, and at the end we build up one collect. And in this slide, you can see our full architecture. So we believe that with imagery and together with the insights and the delivery, we can make sure that we achieve our goals. And at the end, this is just a summary of what we are really working on to have a wearable Earth. And this is the work of so many teams doing really great job. So now, as I said, I wanted to show you some examples, and I'll show you the 50 centimeter resolution imagery, which, yeah, I have it here. Our constellation of SkySats was initially flying at 500 kilometer, but then they were lowered to 450 kilometer. So this image is showing the collect that we got before, or at first place, sorry, with the 500 kilometer altitude. And this is the same image having being obtained at 450 kilometers. This is an image of the Museum of Light in Birmingham, Alabama. And if I can go back and forth, you can easily see how the planes are well or better defined with this second image. I have also another example. Maybe you are familiar with this place or you might visit it, Madrid. Also in the left, we have the 500 kilometer obtained image, and on the right side we have the 450 kilometer. And in the higher resolution image, we can see the street lines better defined as well. And finally, we have an old terminal in Shandong, China, and we can clearly see how some features are now clearly visible. So I will now jump to the tasking dashboard. So let me go through the correct page and I'll share the screen again, sorry. Yeah. So one of the tools that I mentioned before we use to task our satellites, our SkySats, is called the tasking dashboard. And I will have I will start with the demo session, but before explaining just a bit of what we have. After I do the demo part, I think I am sure you will better understand. So from the right side, we have a table of all the orders that we have already submitted, of course, for testing purposes. And yeah, some information, just information that is linked to each specific case. We also have some filters that we have applied already based on the status of the orders to have a quick access afterwards. And we have a user menu that I will also go through. To log in the tasking dashboard, we normally only use credentials, a username, and then a password. And this tool is used for teams internally in Planet and also for our customers externally. So the first thing I do is showing you how we create an order. And for that, it's as simple as just clicking on Create Order icon. And we will have something like this. So we will need to provide some parameters in order to create the order as we wish or the customer wishes. So I first start providing a PL number, which is user or contract unique identifier number. And we will use the one we have for testing purposes. And after we have provided the PL number, we can see that we can select one of the products that we offer. I will not be talking about express tasking because this is a product we are still on, it's in progress and testing phase, but I can explain you about the last three products. So for the order locking product, we let the customer ingest an order and also see the imaging opportunities that he or the customer can have within the next 7 days for this order. So at the end, what we offer is just a imaging window to make sure that they capture the order over the area of interest is going to be collected. We also have monitoring tasking, which we, as the name says, we monitor one specific AOI with a defined cadence. A cadence means daily, weekly, as I mentioned, monthly or sub-daily even, and over the same AOI. And finally, the flexible tasking is just an order that we ingest and we can take the image within a specific TOI, so it's flexible. Finally, well, yeah, I can choose one of them. Maybe to start with the flexible. So I want to change to the flexible, and yeah, maybe of course something very important right from the beginning is the name, but this is something we can just provide at any time. So let me provide today's date, and this is going to be for flexible. Yep. So after I have provided the first parameters, we now need to define the area of interest in which we choose point, line, or area. So I explained you already the point and line, but in this case, we can also provide an area order, which is very simple, and I can also show you in a second example. So if I need to provide the coordinates, I know by heart the coordinates of the place where I was born, so I will directly jump to it. Yeah, and it's a very small town, but it has a very beautiful volcano. So yeah, sorry, I was too excited. When I provided the coordinate, as you might have seen, I was able to get the point shape, the dimension 5 by 5, but I can also shift as the place where I would like to have it captured. So it's a very nice feature. We can move it or play around, and when it better fits, then, and when we are satisfied, then it's fine. We can also see the details, the dimension, the area, and then we also need to define the time of interest. So if I want to start the collect from today, and maybe I would like to end by the 20th of June. This is up to us, and it can be at least 14 days. After 14 days, let me check another one. Let's say end of May. And for requirements, we can choose between image or stereo collect. An image is something that I think it's already clear, but an stereo collect is a collect that will, it's something, it's two images collected, 2 or 3 images collected over the same area. And those products are mainly used to have 3-dimensional visualization. So let's keep with the image type, and then we also can define some satellite elevation angles, but this is something we use by default, and we will keep as they are. We can then go to the next step, review the order. We can see the AOI where it was placed and the information that we provided. And if everything is fine, we can just confirm this order. After we have confirmed the order is directly sent to our scheduling system, and it's going then to be part of the images that we are supposed to be obtained with our satellites. So let me go back to the initial table. And here you can see clearly that our order is already placed. The status is in progress because it's already starting. And we can see some of the details that we already provided initially. And with this table, we also have some other details. We can display more columns to be shown in the table of content, very specific details that we have for cases or whenever the customer needs, but it's a very, very user-friendly. We can also be able to export the table, work with it later on. But also we have the nice chance to see the orders, how they are geographically distributed. So when I change from the list to the word map, we can clearly see everything that was listed now displayed where they were tasked. So if I zoom in into the place that I know I provided an order, it's going to show where it was. I've been testing quite a lot, so you can see how many orders I've been providing over the same place. So yeah, this is a very, very nice tool that we can use. And if we want to now reduce the view, if there is any need to only see the orders that are in progress, I can also apply some filters. I have the option over here. I can add a filter. I can choose, for example, the status, and I can just click on in progress. And then we will get only 4. And if we go to the map again, only the 4 in progress are going to be shown. So this is really useful. And the status of the orders differ, of course, based on the situation. If we were able to get one collect within the time of interest, and making sure of the specific parameters that we provided, then it's going to be considered to be fulfilled. So let me show you one example. We have a fulfill order here, and we are going to see the captures. So once we click over one of our orders, we are going to be also another kind of window is going to show the information of the order. Again, also like a summary of what we have provided from the beginning. Then we have another tab. The second tab is the captures. So in this case, we can see how many captures were clearly collected after it went through our quality control process. And we can also see the history of the order. We can see when this order was ingested, how if the collection started already, and how all the collection went on until the day it was fulfilled and it was set to success. So I can also choose one of the orders and the images. I can click over it. And yeah, as we can see, this is a very nice image that we collected and the information provided here. We also provide a specific naming. So you can see some names are being very specific, which is the satellite that we use to capture this image, the satellite name, and together with the date and time when this order was captured. So we can also download the AOI as GeoJSON or copy the AOI from this tab. And we are also able to set some email delivery. So if you want to know or to get or to be informed of how your order went on directly to your email address, we have the email setting here option down in the menu, user menu. And from this you can turn on or off, depending on how you wish, to be notified if your order was created or if your order was expired. It means that it was it might have got some collects, but they were not good enough or satisfying, or we were not fulfilling the number of captures that we expected. Different reasons. If it was fulfilled, so different options to be defined as you prefer. And I can also, and I would like to really quickly show you how it works when we a GeoJSON, sorry, file. Oops. Now let's check monitoring order. I will now use different name, and I now want to provide a line. So if I know the coordinates of the region, let's, as I said, I know them by heart, but yeah, we have a line. We can also move the line as we need. We can also shift it or rotate it, sorry, we can rotate it, or we can also change the dimensions. We can also modify the initial dimension. This is a very nice chance that we have. And for the monitoring orders, we just need to specify how often do we want to get these captures or this AOI to be captured on a daily, weekly, or monthly basis. We can choose every 1 to 2 days as we need, and how many times we want it to have. So if I want to have a daily basis for 15 days, for example, then I will see how this is going to be a schedule from the 21st of April until the 6th of May. So this option is also very nice to use. And I can also show you the area order. So let me go back to the flexible tasking, which allows the area order. And here we can already provide the input as a GeoJSON. And I have it already. Oops, sorry, wrong here. So yeah, if we have the JSON file already created, we can afterwards edit. There is the chance to move or also shift, edit vertices as much as we prefer, and the rest of the details, it's also clear. We can also upload a file, so geo files, mainly KML, shapefile, different options. So now it's more open, and I think it's really clear enough, and I can now quickly show you the order locking. So for the order locking, I can again try the point. Okay, I would like to move it. And now in this case, the next step is going to be to choose the imaging window. So as I mentioned, the customer will be able to see the imaging opportunities after 7 days from the day from the starting date. So this is going to take just a while, and we can see the options. If we want this AOI, this area of interest, to be captured on the 14th of April at the 14 p.m., then I can choose confirm this window, and I can then review the order. And once the order is everything is fine with the order, I can go ahead and ingest it as well. So this is very easy to use, and this is really making our lives easier. So yeah, I hope I fulfill the expectations, but we still have 5 more minutes for any question or something you would like to know. I can go back to the slides or keep on this page. But thank you very much for the attention.
Thank you. So please, if you have any question, write them in the chat and we can answer and we can forward them to Carolina. The first one is always the hardest, I know. Okay, I actually have a question, which is like right now you have, so the process is, okay, we have a question from Phil, so I'm the less interesting. Please tell, Phil is curious to know how much it costs to monitor, like for example, a 5 kilometer square daily. Like, can you give us a sense of the price that's
Okay, unfortunately, I don't have those details. So I will, if there is any special needs, please feel free to contact me via email, and we can then reach the team that it's related to our sales and prices.
That was just curiosity, just say that.
Yeah.
Yeah, great. Makes sense. Yeah, I'm also really curious to know. But I suppose this really depends on the clients and things like that. So what I wanted to ask is actually you have like some orders basically, but it can really depend on the weather, right? I mean, like for example, in Berlin, if we ask something today, then we could not get a clear image. So how do you make sure that will work, or how do you account for that basically?
Yeah, it's a great question, and for sure we have optical images, or we are taking optical images, which is the drawback, the weather conditions, and this is not happening with. I know if you have heard radar satellites, so the cloud condition is not a problem. But yeah, this is the reason why we are able to do some attempts. So if something is not in favor of mainly the weather, we for flexible tasking specifically, depends on the product part, but for flexible tasking, if it is really not a possibility, it was really cloudy, we are keep on tasking. So might be that within the time of interest, everything was not that good. But we also try to make sure that we do the quality control as we really expect the customer to be satisfied. Sometimes we get a specific percentage of clouds, which is fine for the customer. So we have to deal on a scene or collect basis more than scene collect basis, and we see how the scenes are. But really checking or cross-checking with the captures that we get.
Yeah, makes sense. Thanks. We get a question from Manuel. Who are your biggest client of your services products? If you are, I mean, I don't know how much you are allowed to disclose, but who is using your service basically?
Yeah, so I would like to have to provide an overview of the usages more than customer names. We are providing products or collects for universities, for example. So they are doing research projects and they would like to have clear images of the Earth. I personally, I had a nice experience. I was able to work not with satellite planets images, but with Sentinel, which are free, to be able to get the displacement of the Earth after an earthquake. So this is very interesting to be used in the scientific community. We also deliver our products to newspaper. Maybe you knew that we had a crisis in the Suez Canal. So we were able to take images of this big tank, or I forgot the name, but this was a really huge tank being blocking it. So this was really useful as well. And there are specific clients, customers that would like to use this to assess changes over the time, because as I mentioned, we also have archive data. So we can have data from before, analyze changes, mainly environmental changes as well. So the usage is really broad.
Thank you. Hope that answers your question. I also get some question from YouTube. I'm not sure if it's if there are anything like that, but can you use that to implement in our apps? I mean, is there any kind of thing that is there an app or a way to show that in an app on a way, or like you just get the image and then you do whatever you want with it?
No, we have an external app which is called Planner Explorer, and this app it's I will say very similar to Google Earth more or less. So we can see the collects in the base map. It's very nice to see the naming of the streets and so on. So it's much more detailed, and we have this as an external tool as well related to the tasking dashboard. The tasking dashboard is really specific for customers and the internal use, as I mentioned. While Planner Explorer being one of our apps, you can access for 14-day free trial, and you can have a look of how it works as well.
Cool, thanks. We also get a question. Can you tell us more about the scheduling of order to so how does the scheduling of order to satellites happen? So
yeah, so then after we ingest the order, as I mentioned, we have a scheduling system that it's compiling all the orders that we provided at the end. And this information is going to reach the satellite once the satellite is crossing over our antennas. So there are communication antennas placed over specific regions of the Earth. And once the satellite's flying over those antennas, then we are able to send the information. And the satellite itself will also collect, and everything afterwards will happen. We are providing the detail as much detail as we know, as you see how we need to provide, and afterwards we are waiting for the collect to be obtained. So if I can choose the one, I can choose the second one. I ingested here in the, so we can see from the history. that I submitted the order, the collection has started, nothing yet has happened afterwards. But if we go to, let me check one which is already fulfilled. Sorry. Let's see the history. So you see, we have the collection has been scheduled to be at a specific time. And once satellite is, we know it's going to pass over this region. Then the capture was obtained, it's downlinked, and then it's going to be processed. Once the capture is processed, then it's going to be published. And when it's published, it has to be manually assessed, unfortunately invalid. But if we get another one, still the same process goes on until we have it as a success. More or less, this is what I can describe. I hope it was clear or answered the question.
Yeah, sounds. I mean, I suppose there is a really big logic behind of how you define which satellite should do which thing and how, when, on which thing it should transmit the data and everything, but not something that you can explain in 5 minutes.
Yeah, it's quite a process.
Also, we also get some question. So why did you decide to put the satellites in the 450, 500 kilometers and more, and not more closer to Earth, in order to provide an even better resolution?
Okay, so not being really satellite expert, I know there are some problems that will not allow the satellite fly at such lower altitude. So the 450 was possible because the satellites have propulsion and they were able to be lowered. But reaching very low orbits, I think it's a real challenge for the satellite to be properly working.
Atmosphere, probably.
Yeah, exactly.
It's getting too thick so that it's slowing down the satellite. Oh yeah, also some question, number question, if you know, let's shoot. What's the data exchange rate between the base station and the antenna, the base station antennas and the satellite? So, do you know by any chance the rate? How much is able to be transmitted?
Oh no, this is a good question. I really don't know how much data it really is, but I think it really depends. I don't know the maximum or minimum values, but it depends on where the antenna is located, how much information by this antenna was gathered, and how many orders we have been placing or ingesting. So it's I think a number that it's very much changing, but I really don't know how much can be.
Great, thank you. Yes, actually, and I also had the same question, which is Python used in this context? So in all what you are seeing, probably in the backend, is there any Python involved? And
I am pretty sure. Yes, I am pretty sure. And I
yes,
think
it is widely. Yeah. At least widely used, basically Python, except the front end, of course.
Yeah. Is it the main backend language?
Yeah. Yes.
So yeah, Python in space. Really cool. I mean, not in space, but to make things happen in space. I was looking for the word.
Yeah,
sorry.
Correct.
Yeah. Great. Any other questions? Please shoot, or otherwise we'll say I'll just let it open 1 more minute. Any question? Please. Let me just check. Yeah, that will be it. So thank you again, Carolina. It was really nice to see this product developed by Planet Lab. If you have any question that pop-ups afterwards, you can always ask them afterwards. We'll have another meeting using Wanda, where you will be able to have a kind of more PyData physical meeting setup, where you'll be able to move around and see other people. We share the link at the end. So if you want to have if you have more questions. So
Thank you.
now,
Thanks a lot.
Thank you very much. So what I propose now is to have a few minutes break. So I propose to start again at 8. So if you want to grab a beer, or pizza, this is kind of the theme of the meetups usually. So feel free to go. Stay here. We can have a chat if you want also. And after that, we will welcome the second talk. Great. We will start soon. But we need our speaker. Yes, he's here.
Here I am.
I was afraid.
Ready to roll.
Oh, no, don't leave us now.
No, ready to roll. Ready to roll.
Okay, great. Oh, that's a bit scary. We got enough bump on the road, please.
Should be
Great.
smooth from now on.
Yes. So welcome for the second break. I hope everyone has some beer and some pizza or any non-alcoholic beverage it seems fit for the time being. And let's go to our second talk with Wojtek, who will talk about how to detect silent failure in ML models. So this is your stage.
All right, thanks a lot for the intro. And without further ado, let's delve into it. Just if you could tell me that you can see my screen.
Yes, we can.
Cool, perfect. So what I'm going to talk about today is how to detect silent failure. But before we delve into that, let me do a quick intro. So I'm Wojtek, one of the co-founders of NumFOCUS. We are a very small VC-funded startup that deals with AI monitoring. So what we try to do is basically answer the question that is asked here. We're trying to detect silent machine learning failure and then address it in some way, which seems to be quite relevant to basically almost every data scientist that right now works in models that make it to production, because models tend to fail a bit. And why do I have something to say about it that might be interesting? So I used to run a machine learning consultancy. We did end-to-end projects. And then at the end, clients were always asking us, okay, now what? How do we make sure that this thing still keeps on working? And we didn't really have an answer for that. So we started kind of investigating what happens with machine learning after it has been deployed, and if it fails, what can we do about it? Also, just before we delve into that, let me say we are hiring. So if you'd like to work in a very cool, nice, remote, high growth startup, working on core product, working on basically machine learning for machine learning, you are most welcome to apply. I'll do a bit of, I'll talk about it a bit more later on. So let's talk about how to detect silent machine learning failures in production. So what's on the plate today? First, we'll just do a quick definition of what is model failure. Then we'll, so basically just, what it is. Then we'll explain what happens when the models fail, what are the consequences of model failure, and why this is an important thing to tackle both from technical and business standpoint. Then we'll talk about the causes, the reasons why machine learning can fail and probably will fail in production. We're going to follow up with detecting machine learning failures, so really the tool set for that, the machine learning monitoring part. And then we're going to have a very quick engineering slide about how to incorporate machine learning monitoring tool set, either one you build or one that you decide to purchase, into your infrastructure. So let's start with a running example that I'll be using throughout the presentation to make the machine learning monitoring a bit more real, a bit more grounded. So imagine that you're a data scientist at a big bank having 30 million clients, and the biggest product line is long-term loans, maybe mortgage loans. And working on the core machine learning model that basically does credit default prediction. So we take the credit scores and the customer information, and based on that, we try to predict whether somebody's going to default or not. And that way we can approve or disapprove a loan. We're going to define the loan default as non-payment with 1 year. So it's not known immediately. We need to still wait 1 year to really see whether this person is going to default or not. We need to optimize for some kind of business metric. Let's pick something that's typical in fintech and banking. So we try to just predict, optimize for ROI, return on investment, and we're going to adjust it by some risk factors. So the more risky loans will have lower ROI, even though expected ROI might be higher. And of course, when we have a business metric, we want to approximate to using some kind of technical metric. The one that's widely used everywhere in data science would be an F beta score. And in case you forgot what it is, here's just a very quick overview and an equation. Basically, what it does is we try to weigh the true positives and true negatives in a way that really reflects the business problem. So let's say that people that apply for a loan and then default are more problematic than people who would not have defaulted, but we still reject them. So we need to weigh it in some way. So imagine now we have this model. This model is bringing a few billion a year, but if the quality of the model decreases by even a few percentage points, we go from making billions to actually losing billions, and the company might go bankrupt. This is actually not an exaggeration. That's how loan applications work on big scale. And if you systematically underestimate the risk, the bank might go bankrupt. This is exactly what happened in 2008. So we have our example. Now let's talk about machine learning failure. So machine learning failure can be characterized by three things. The silent one. First of all, everything looks okay. The machine learning system still outputs predictions. It's not an obvious failure. You've seen no errors. Predictions are made if you look at them, and if you have a business person look at them, look at 50, 100, 200 examples, they will all look reasonable. The loans that should be rejected will be rejected. The ones that are kind of on the verge will be on the verge. And everything looks fine at first glance and second glance. And you don't really know whether performance is good or not, because you will see, using our example, only the real label or real ground truth a year from now. But if model fails, the performance will have degraded significantly, which is, of course, a big problem. So why is it a big problem? Let's talk about the consequences. First of all, in basically best case scenario, you will see a significant decrease in ROI, because maybe you're pricing your loans too high, you're maybe rejecting too many people. And that's still kind of good failure, because you're just losing money, a bit of money. But it might get worse in a sense that you're not only not making any money with your machine learning model, which is in the end the goal of all machine learning models, or almost all machine learning models, but also you might start losing money. You will have unforeseen and hidden risks. Here, using our example again, you can have systemic risk if model for some reason always approves some loans that shouldn't have been approved, and it does it in a systematic way. The company is almost guaranteed to go bankrupt when these people start defaulting a few years down the line, all at once in very correlated fashion. And that's not it. That's not the end of it. We can also have problems with the downstream failures. So imagine that marketing and customer acquisition department also tries to get the clients that give the highest ROI. And the highest ROI at first glance would be the people that you approve for risky loans. But if this risk is not taken fully into account, your marketing and customer acquisition channels will go for the people that should not be given the loans at all, and it will only make the problem worse and worse. So the consequences can be serious, but now let's look at the reasons behind it before we start talking about the solutions. So the basic reason is really, really trivial. As your models are trained on static data, normally, unless you use online learning, which is right now still very rare in business. So you train the model on training data set, you test it, you validate it, blah, blah, blah. It works good, ready to be deployed, you deploy it. But as time passes, the environment changes. So the input data and the patterns between the inputs and the outputs, of course, will also change. And that means that your model is no longer a good representation of the reality. So it will stop working and fail silently. Here, to have a very specific example, let's assume that the model has been trained on all population, but now more and more young people apply because maybe the bank created new, really nice, sleek web app or mobile app, and people actually start using this bank. And young people tend to be more risk prone, but the model didn't know that. We didn't model it because there was just not enough young people to take that into account. So machine learning model will systematically underestimate risk, and that is basically a recipe for disaster. This is the kind of basic failure mode. That is the main and kind of idea why models fail in production, because things change. Now let's look at the less obvious things. One of them is that every machine learning model, as it interacts with the environment, as it interacts with the population, actually also affects the population, and the population will affect the data that the model ingests. Imagine here that the customers consciously change what they actually say in their law application, what things they hide, because the model needs to be fully can be fully explained, as this is the regulatory necessity. So customers will start trying to fool the machine learning system, and in time they will succeed, which might decrease the performance of the model. Another thing kind of obvious is that we can have stochastic shocks, things just coming from the outside that change how customers behave, how loan application process looks like. We can have a new regulation that imposes lower down payments, so people are more encouraged to take loans, and the system was not trained on that population. Our model is not used to that, so it will not take it into account. And the last thing is that imagine we expand even from Berlin to Bavaria, we'll have kind of different population there, different risk profiles, people will behave slightly differently, and the model again is not used to that. And then let's talk about last two reasons. One of them is very long cycles that we haven't captured in our data. One example here would be the the boom and bust cycle, which can span 20, 30, 40 years even. And if we take 5, 10 years, which is normal, to use the data from 5 to 10 years from now, we will not be able to capture this cyclical nature. And as we enter new phase in the cycle, the model will not be able to really capture the patterns that happen during this part of the cycle. And the last thing, kind of obviously, is that as our data become more noisy, because maybe there's new bugs in the credit scoring system, we'll lose performance. But that's kind of a given. So we have the reasons. We know what happens, we know the consequences, and we know the reasons. Now let's really talk about the most important thing here, which is the tool set of how to actually detect it. So detection of machine learning failure is hard because it's silent, right? And there are some ways to try to approximate it, try to find the potential secondary causes of machine learning failure or secondary symptoms. And one of them is data drift. Data drift is basically change in the data input. So not the data outputs, not what we try to predict, but just change in the distribution of data inputs. If we look at 2D example that I've shown here, we see that the data points were kind of clustered together, and still the model managed to find a very nice decision boundary between them. But as time passes, maybe they will really become bimodal. And right now you would see that the decision boundary in the second image doesn't really reflect how the model would create it again if it was retrained on the new data. And it's easy to spot it, it's easy to do it manually to make sure that there's a problem. But what if you need to work with hundreds or even thousands of features? Then, of course, this is not possible to just model it like that and look at it visually to see if there's change in the data distribution. So we need some kind of algorithmic and statistical tools to detect that. And as the data changes, it might be that right now the model is making predictions on new regions in the data that it was not trained on, so it will not capture the patterns there, which might, of course, cause failure. So first and simplest way to solve it is just do few univariate statistical tests, something like Kolmogorov-Smirnov test, or chi-square test, or exact Fisher test. When we look at every single feature separately, we look at the distribution previously, either during training or maybe last month, last week, last day, and compare it to the current distribution. And if it is statistically different, it means that we do have data drift, and this data drift might be kind of a symptom of incoming model failure. If we want to look at it not from the perspective of just one variable at a time, but we want to look at them at the same time, very nice way to do it is to just run anomaly detection. We feed our anomaly detection algorithm something like one-class SVM or isolation forest. We run it on the data where we do have the labels and we know what is the performance. And then as the time passes, we will just see whether there's more and more anomalies coming. And if we see more anomalies in our current dataset compared to the previous dataset, it's a strong indication that data drift is happening. And again, that might cause problems. And the last most advanced way to detect data drift is using generative adversarial neural networks. When we train the GAN on our training data, so it learns how to parrot, how to mimic the training data, and then we use the discriminator part of the network in order to basically see if the new production data is significantly different from the training data. That way we can really capture all characteristics of the data set using a neural network. It's the most advanced way and should be the most robust and most efficient, but of course GANs are very hard to train and they tend to get stuck in local minima, so it's easier said than done. Now, I'm going to walk you through a mini example of how to do it just when you can, tomorrow start working again. And if you're curious about whether there's actually data drift currently in my model, what you can do is you import one of the statistical tests I mentioned. You could, for example, import Kolmogorov-Smirnov test to work on continuous data. You take one feature that you're interested in, you set the default p-value to 0.05, you run the test compare for a given feature, comparing the previous month distribution with the current month distribution. And if the result of the test is that the distributions are different with p-value below 0.05%, it means that the feature has drifted. Very simple thing, but just something for you to try out later on. If you want to work with categorical features, then you would need to use chi-square test. For binary categorical features, you should normally go for the Fisher's exact test. These are just names. They work in a reasonably similar way. To give you a quick overview of how the KS test works, it takes two distributions. It looks at the cumulative distribution, and then it basically computes the area between those two. And if it's sufficiently big, it tells you that there is drift in the data. So now let's move on to the second way of trying to detect whether the model has failed, and this is the concept drift. Concept drift can quickly be defined as change in the decision boundary. So again, we have a 2D example here, and on the training data, our decision boundary has been determined, or maybe it was real like that. And now if we had looked at the labels, we would actually see that the decision boundary looks like this. So it's completely different. But the patterns are different, the model doesn't work anymore. And that, of course, strongly implies that your model has failed and your predictions won't be as good as they used to be. How do we try to really detect concept drift? This is hard in itself. And if we have access to labels, we can do a few simple things. First one would be just to do the correlation analysis between inputs and the labels, not the outputs, but the labels themselves. And if we see that the correlations themselves are drifting, then it means that we have concept drift because the pattern between the inputs and the outputs has changed. Then another thing what we can do, a bit more advanced than just correlations, we can create a model, your normal XGBoost, let's say, fit it on the training data, then fit it again from scratch on last month, last week, last day, and then see if the model parameters are significantly different. If they are, again, we're just right now trying to see if the mapping between the pattern, between the inputs, the outputs has changed. If it had, then we have concept drift. And that is all nice, but we don't really need it that much if we have access to labels, because then we can just measure performance. So what can we do if there's no labels? So we don't have the ground truth, the actuals. And one thing we can do is we can measure the drift in the current feature importance. Imagine we have our XGBoost model, and the model has certain feature importance. Maybe the most important thing is the credit history, then it's the current income, and then maybe location. We take that and we look at the feature importance for every single example and then sum together using something like SHAP values in the training, and then we compare it in production. It might be that because of the data drift, actually the the features that tend to be important for every single example in the production will be slightly different than the one in the training. And if we all sum them up together and average them, the feature importance is going to be different. And that kind of implies that there's still concept drift on top of just data drift. Now, moving on to the last part of detecting machine learning failure. Here we try to directly measure performance, or at least estimate it. And the easy thing we can do is to just measure this and do statistics on the metrics, on things like F beta scores, F1 scores, precisions, RMSEs, etc. If they change, then of course our model is failing, as simple as that. And again, things get interesting if the labels are delayed or not available at all. Imagine that you're doing document classification. You will never really have access to labels because the machine is doing the job that the person was supposed to do. So right now you will never see the true label unless you actually have a human do the same work all over again, which defeats the purpose of using machine learning in the first place. So what we can do then is, instead of trying to see whether the model is correct or not on every single label, which basically is recreating the model, we can look at the aggregate performance, which funnily enough is easier to do than just looking at every single example. I will not go into details now, but happy to answer questions later. Why is that? But we can estimate the aggregate performance using things like data drift, concept drift, the features itself, statistics. We put that all in the model, and another machine learning model built on top of our current machine learning use case that takes the input data from the past as inputs for machine learning, inputs and outputs from the past as inputs to the model. And then as outputs, we have the aggregate performance of the model, again, from the past on our historical data. And we build this model, we fit it, and then we can estimate the performance on current data set when we don't have the labels. It is not guaranteed to work. Our current version is just a prototype. It seems to be quite robust, but of course, it's an open question, and by some definitions, it's impossible to fully solve. And then the last thing, again, something easier, is to do statistics on business KPIs. If we have access to direct business KPIs, then of course we can just look at them and see how they change. Maybe it would be the volume of applications, etc., etc. And if it goes down, then it's a problem. So that was how to solve it from kind of algorithmic perspective. Now let's look at the architecture, the engineering perspective of that. What I have here is a very simple, radically simplified kind of diagram of how a typical machine learning system looks like. So on the left here, we have a business process, which emits some kind of data that is taken as a model input. So your typical features, right? Credit score, credit history, income, location, occupation, things like that, for example, with our running example of credit scoring. So this is the model input. Then we have a machine learning model that does its magic, and then it outputs model output, obviously. What we need to do is we take those two, then you take it into your machine learning model, machine learning monitoring system, whatever it is. You take those two things, you compute data drift, you compute concept drift, you try to estimate performance. And if we have also access to the database, to the downstream data, things like business KPIs, things like labels or ground truth, so whether the model has failed, whether the credits was successful with it based on has paid back the credit or not, and maybe some other data. If we can get access to that, we should also take it into account. And the last thing, if we do have access to the model itself, it will also allow us to directly see what are the assumptions that the model has, whether, for example, it's strictly linear model. Then if there's some new non-linear relationship in the data, we know for a fact, we don't need to check it, that the model is not capturing that, so there's a problem. If we don't have direct access to the model, we can still create a surrogate or fake or shadow model, which should quite well approximate the machine learning model that's there, but maybe the assumptions won't really be the same. Then we take it into our machine learning system, where we compute all these things, and then we can output it in a dashboard as notebook instance, just as an API, so that the downstream services, something like maybe training framework, can take it and act on the alerts. If there's an alert that the model performance is not good, and the reason for that is that the data has drifted, maybe just retraining will fix it. So we take that and then we use it later on. So that's basically it. What I wanted to share before we finish is just few resources. There is a kind of decent-ish library called Scikit Multiflow, developed by guys from the data streaming community. It only works with data streaming, so it will not work out of the box on most machine learning use cases. But nice thing about it is that they do have a lot of drift detection algorithms. They're a bit more advanced than simple statistics. So yeah, you're welcome to give it a try. Few of our competitors, just gonna go with the biggest ones. Fiddler AI, they're based in Silicon Valley. Arthur AI based in New York, enterprise stuff. And then when it comes to interesting things, a bit more self-promotion, I have a blog on how to get started with monitoring. Give it a read if you like it. And then a few papers, kind of seminal papers about how to do drift detection. Basically, these two guys are the biggest names when it comes to data drift detection. João Gama is Portuguese. Albert Buffet is from Paris, I think. So give it a go. You will see this presentation later. You can just click on the links. You don't have to take screenshots, but you're welcome to. And last thing, more self-promotion is, we're looking to hire data scientists and also data engineers, but mostly data scientists currently. So come work with us. We are super cool people, very small startup, 4 people. We are VC funded, so we're not gonna run out of money anytime soon. We offer good salary, we offer stock options. We are fully remote. I live in Portugal. One of my co-founders right now is in Spain, another in Belgium. And yeah, we're cool people, join us. Also, feel free to add me on LinkedIn, send me an email or anything like that. Also, if you need machine learning monitoring, also let me know. And that's it. Thanks a lot.
Great. Thank you very much. Thank you, Nani. Sorry.
So questions?
Yes, actually, we have one in the chat. Okay, so let me read it. How far does the noise in the data and the overfitting of the model influence silent failure of the models?
So influences what?
Influence a silent failure of the models.
So I would say that the more noisy the data is, the more robust the models will be, surprisingly, because robustness basically regularizes the model. They will be much less performant because you have noise in the data, but that also means that they will, whatever performance they have will generalize quite well, so they will be more robust. And the models that are really, really optimized as much as possible, and the more they overfit, the more overfit they are, the more you are likely to experience silent failure. If something is really overfit, or is not strictly speaking overfit compared to the validation set, but overfit compared to reality, once you deploy it, you actually see that the data is slightly different than in production, slightly different than what you trained it on, and the model is going to fail. So here you should also take into account that even injecting some noise would make your model more robust.
Can I jump in with a question?
Yes, please.
Okay, so just one question. How much are the costs of this right now? Like how would you estimate the cost multiplier of monitoring in production compared to of developing the system in the first place?
That's a good question. I would say it's more or less negligible compared to development. When it comes to deployment, maybe around 10%. We honestly did few calculations when we were raising money, how expensive monitoring is going to be in the future. And we ended up at around 10% of the general system operations. So not really compared to development, but compared to deployment and operations. You should add around 10% to make sure it's monitored well and everything goes fine. which I think should generate decent ROI, given that if it fails, it will not only wipe out all the value it has provided, but take a big chunk more on top of that.
Thank you.
Other question? I have a question then, if no one's. So what are you focusing, or at some point you talked in one of the slides that you said like you have a bigger model which take the model inputs, the model that input the data set and train another model on top to be able to predict the aggregated statistic of it.
Mm-hmm.
Is it what you are focusing on in NaniML? Is it this part, or is it, yeah?
Yeah, it's actually one of the core things that we're working on right now, because people really want to know what happens if we don't have the labels, how can we still estimate performance? And they see it as complete witchcraft. So that is something that we're trying to solve, because it's, first of all, it seems to be needed. Basically, everyone we speak with says like, yeah, if you can solve it, yeah, we want it. And also it's very interesting to work on because it's a very hard technical problem that has not been fully solved.
Yeah.
So that's very much is our focus.
How do you see the product? I mean, will that be open source, or like, do you have a kind of idea of how you want to develop it?
Yeah.
Afterwards?
So maybe I was a bit too humble when it comes to our stage. We actually have a working MVP. So it's ready to be deployed. It's right now is not open source because the code behind it is kind of ugly, but it works. It's there, and we're ready to, like, we're rolling out already. We are working with companies and monitoring their models, doing first pilots. So it's their early stage, but not that early. We are past the concept stage. And by default, this is enterprise SaaS, because companies are normally very wary to give their data away, even to a pure product. So they prefer to keep their data inside their cloud. And for this reason, we always need to implement NaniML inside their cloud. So it takes some integration, some manual work. But in the future, of course, we plan to release some open source components.
Looking forward to that. Do we have other questions? Oh, yes, we have some questions. Okay, a question from Phil. If you are working with big data, don't you find that your significant tests show up as significant even for the tiniest drift that wouldn't matter in practice?
Yeah, so it's all about tuning. Interesting thing is, of course, if you do it in a very naive way, when you just run a million tests, some of them will, of course, turn to be positive. So you need to take that into account and you need to adjust your p-values, even if you work with simple statistics. And when it comes to big data, yeah, that's all about fine-tuning. We want to have as little false positives as possible, but of course still detect all the cases of failure. And it's a hard problem, but it's kind of a trade-off between false positives and false negatives. So we don't, because we take that into account. But if you approach it in a very naive way, you would indeed get alerts all the time.
Makes sense. Question from Namo. What kind of clients are you serving at the moment?
Yeah. So we work right now, we're switching mostly to work with fast-growing startups, but we also have two enterprise clients that we're working with, mostly fintech, but also one media company that we're working with. So it's either big enterprises or startups. The reason for that is startups are very easy to work with and they have very interesting problems, and we can also get kind of validation that the problem is real. And enterprises are very interesting just to see how we can potentially deploy it at enterprise, because this is not an easy thing to do.
Also another question from Namo. Do you look at fairness of the models? Not sure. if you can.
Yeah, we can possibly, it's on our roadmap. We want to start with bias first instead of going, just simple bias detection in data, especially change in bias. If there was some bias that was taken into account, and now new type of bias appears in the data, because maybe, marketing targets mostly males or mostly old people, and there's new kind of bias in your population. You will be able to actually detect it automatically right now, just looking at the feature distribution that it changes. And on our roadmap is to address it specifically, but it's not there yet.
Great. Thank you. Do we get some other question? Not at the moment. Please feel free to ask. That's the time. Where? Okay, so you are in Portugal, one is in Spain. Where are the two others?
In Belgium. So we are legally
Belgium.
incorporated in Belgium. But yeah, we are fully remote as long as you are free to travel within the European Union. It's all good.
Great. So if no other question, I propose to stop here. So thank you again. A really interesting presentation. And I will stop the recording. We don't need it anymore. And I will also invite the people who wants to join us in Wonder. So as I said before, it's a kind of you can see of a 2D plot, like a map, where you will be a small dot on the map, and you will be able to move around and get close to other people. And then at this point, you will be able to start the conversation. So if you want to have some question directly with the people, so Wojtek, Carolina, if you are joining also, are you joining?
Yeah,
Yes?
I'm joining.
Great. So if you want to have some more questions about the company, etc., feel free. And Carolina also, if you are joining, or might have some other question. So I will post it in the PyData meetup in the comments, and I will also post it in the chat. So if you have any question here, you can post it here. You get it here. And if you are in the Zoom, in YouTube, can I also put it in YouTube? Up, we also have it in YouTube. Great. So that's it. Thank you very much for the one. Thank you for the two speakers. Thank you for the audience. We'll stop here this part, but you are welcome to join in Wonder. The name of the company is so great. Okay, see you soon, I hope. Otherwise, see you for our